Hi everyone, welcome back to another episode of my build. In this episode we're looking at the control system for IG-11. How does this guy operate his stepper motors for his head? How do the servos work? What turns on the LEDs? All of that kind of stuff is going to be answered in this episode. So stick around, let's look at the control unit for him. And eventually I'll release these files, but not until I'm pretty much finished my build. But for now, let's see how I've got this guy operating with some electronics.
Here's a quick fusion explanation of the detonator section of my build. So let's just take a look at that. So it starts off with this servo mount, and it's got just a spot here for the wires to come through. This is mounted flush to the back, and then the servo goes into there, it just gets screwed in. So you're basically going to have to screw the servo in and then glue the whole thing inside. And if you have to replace the servo, you'll just have to pry off this piece and either print another one or just use the one that's there if it's not damaged. Then we have the extender. It goes on to the existing servo horn that's there. It'll be snapped on. I don't have the servo horn on there, just the extender that I made. And then we have our tube that goes from here all the way to the detonator, and we have a tube insert, and that tube insert, I'll just take away the tube, looks like that. So there's going to be an M3 bolt that goes through here. These are actually flush when you've got it put together with maybe a washer, and then this hole is small enough to just screw that screw into, and then just keep it loose enough so that this can still pivot in this area. And then we have the LED holder. So the wires are going to go through here, through the tube, and there will be a hole right underneath for the wires to pop out. Then we have the sleeve. So this is the sleeve that it rides back and forth on. This is just an aluminum tube that I had. You could use plastic or whatever. And then the detonator goes on the end of it. So if you look at a cross section, that's kind of what it looks like. So this part here is flush with the back of the detonator. There's the sleeve, just starts right there and ends here. I have measurements for all of these as well. And then there's the insert where the bolt will go through. So once that's on, we will have, that's what it'll look like inside of the torso. So let's activate that and show you how this sequence all works. I made a modification to the servo horn. I added this section here instead of just having one long strip right here with this opening for the pivot. I added one to both sides. That way it hugs the tube a little bit better, and I even shortened it a little bit. So what we have to do now is the servo horn that comes with your servo, you just have to cut it a little bit so that it's flat right at the very end so this can fit in a bit better. I just found it works, clears all the gaps a little bit better. So that's just a change that I made. All right, I'm going to show you the detonator section of my IG build. What I've done is originally I printed this part here in a split form, so it was like this. And I did that because I was printing this in ABS and it just would work better. But since then I've bought a different printer and I'm making everything in PETG. So I'm just going to show this as a model. You can see that this part here used to be a plug. It used to be solid, and that's where the detonator would plug into, like that. Okay. And I've remodeled this part of it. And these are the modified files that Andrew put together. So it's got a big cavity here. And I've made this part come straight out here and hollowed it out so that it's going to take a sleeve, an aluminum sleeve, a tube. I'll show you that. And then as the square tubing comes down, the wires were supposed to come through here, but I'll plug this and I've made a hole so the wires can come right through there. And then I created this little servo mount to hold the servo in this orientation. It just glues in, and I've made a special extension to the servo horn, so that's what it looks like. It just snaps onto an existing servo horn, and it's going to be for moving the detonator in and out. So what I have here is a aluminum tube, and I put a hole right here for an M3 bolt, and then another hole here for the wires to come through, and a little plug. So this plug here has a M3 hole in it, so this plug is going to go into the inside of this and just pushed in, so it's going to line up with that hole there. And then eventually I'll put an M3 bolt through here into that so that this can move back and forth. And for it to slide easily, I've got this other tube that is just slightly bigger, so that will slide in and out, and it'll be attached to the detonator. And the way that's going to happen is I've modeled this little piece right here. It's got a hole in the back here, and it's meant for a neopixel ring, so that's going to go in like that. Wires are going to go through the inside here. This tube is going to be pushed in like that. The wires are going to come through out this bottom hole and into the cavity where the circuit board is going to be. And then what you do is you take this, push it through here, glue it in so it's just flush there, and then this will be able to go in and out. So I'll show that to you on another print that I did. This is PETG, and you can see I've modeled the hole inside there, and in the back there is a spot for the sleeve, and then this is the hole where all the wires come through, and eventually the circuit board is going to be attached to this side and to this side. I'll show you that a little bit later, and I'll just show you how this gets attached. So you're going to push this aluminum tube through, and then the detonator can go through, and then it can slide back and forth like that with the servo in there. So I've got another one of these. I'm going to mount that up there, attach it to the servo, and hopefully that'll all work with the sketch that I put together. And as far as the cover of the detonator, I'm going to reprint all of this in resin just to get a little bit more detail. You'll be able to see the LEDs through here, and then these holes here are currently plugged in the model. I've remodeled it so that they're open inside so that the light comes through there as well. You could always just drill those through as well to make that accessible to the LED. So once this is all together, I think what I'm going to do with mine is keep the cover off, because I tried to figure out a way to have a door that would open and close, and it was just too complicated, so I'm just going to leave that off, and then when it does the self-destruct sequence, it'll just open and close like that, or push forward and backwards. So that's kind of how I've set the detonator section up. Okay, let's look at the control system for my IG-11. Now, I'm using stepper motors, so you obviously have to drive them with stepper motor drivers. So in the past, I've put my own circuit together. If you've watched my C3PO video, you can see how I did that. But I thought for this one, why put a circuit together when one probably already exists? So I found this, and I've never used it before. It's a CNC shield that you plug on top of an Arduino Uno to make your own CNC or 3D printer and things of that nature. It has a spot already on top for up to 4 stepper motor drivers, and it seems to have worked pretty good for my application. So I used that, and then I also created this circuit board. It looks rather intimidating maybe at first, but it's pretty easy to figure out once I go through this. And if you're like an average middle of the road maker, you could probably do this with no problem at all. So let's get into how this all works and how it's wired up. So the CNC shield that I bought, this is off Amazon. It comes with a spot for, as I said, 4 stepper motor drivers. The drivers that I'm using are quiet ones. You can get some cheap ones, but for a couple bucks more you can get some ones that don't make your stepper motors whine when they move. So that's what I chose to do. And in order for this board to function, there's a couple jumper wires that you need to plug in at first. So right here where it says EN and ground, so that's engage and ground. So you need a jumper to plug right into there to connect these two. And for my stepper motor drivers, you also need to connect, there's MO, M1, and M2. You need to put a jumper here, here, and here, because I'm using these 3 drivers. So you can see it's all kind of laid out here, nice and easy to plug everything into. Just a side note, for stepper motor drivers, you also need to make sure that they're not putting out too much current for your stepper motor. There's lots of tutorials on that. I'm not going to get into that on this video, but there is one on my 3PO video. You can maybe watch that. So all you do is you plug in your drivers. So you can see there's an X here. So that's the X, the Y, and the Z. And then there's an accessory one, which we will not even be using. So this will be all blank. So for my X, that's going to be my top stepper motor. This is my middle one, and this is my lower one. Now all of the pins of the Arduino are connected to this whole driver along these pins here. So I've gone through and I've identified all of them. So I'll show you that in a minute. And then you also need to power this whole unit with putting 5 volts in ground to these 2 pins right here. All right. Now to drive stepper motors, you also need correct power separately to them. So that's what this entails. So you just plug in your 12 volts, which is what I'm using, right into here, and that will go directly to these drivers and power up your stepper motors. So that's the shield part of it. And let's move down to the connections. So I've made this table here. So you can see that on the Uno, digital pin 0 is RX and 1 is TX. I haven't touched those ones. 2, 3, 4, all the way down to 7. They're already connected to the stepper motor drivers. So this is the direction. The top stepper and the top stepper are on 2 and 5, and the middle one is 3 and 6. So it controls the step and the direction. So the step and the direction. So you don't really need to worry about that too much. It just shows you how it's going to be connected to your Uno in the code. But basically that's all set up for you already. So digital pin 8 is connected to ground when those engage and jumper wires are connected like I showed you up above. And then all of these ones here are where they're going to go to on the board that I created. So I'll show you that live when I actually show you the circuit boards. And then to wire my board, let's just explain my board here, and I'll just zoom out a bit so you can see it. So this is my board, and it's composed of a bunch of different separate components that I bought and just plugged into a perf board. At the top there's an Arduino Nano. And then underneath that, there's a DF player mini, and then a whole bunch of ports to plug in your servos and LEDs. And then I bought this little amplifier to make the sound louder, and that plugs into your DF player mini, and the speaker wires come right out of here to go to your speaker. And then I need to provide power to this guy, so I've got 12 volts coming in here and 12 volts going out to my CNC board that I showed you up above, and then the output is 5 volts. So that's what my control board looks like that I designed. And here I have a diagram of, zoom in here a bit, of what the connections all look like. So it just shows you that these A, B, C, D, E, F, G, this is where you're going to plug in a touchpad, the top stepper limit and the middle stepper limit, and the servos and the LEDs. They all plug right into here, so it's one area that everything gets plugged into. And then I have a capacitor here, I have my amplifier and my buck converter, and then for the resistors, I've got them all labeled right here. So that's what that looks like. So you can see way up here on that guy there, I've got the board laid out here, but I don't have my resistors plugged in yet. I'll show you those live. Yeah, and I also found out that when you're plugging these little header pins into your perf board, it's really hard to plug in one or two separately. They don't adhere very well underneath to the pad. So what I did is I've just plugged in a whole row of them and soldered them underneath, but the only two I'm using here is that one and that one. And you can see that I've cut off these other ones. They're just providing support for this strip to stay on the perf board. And as you see down below, let's go down to here. That's that same board. You don't see the whole strip here. You just see the negative and the positive there. All right, so that's what that looks like. And I also included this. This is what my perf board looked like with all the holes and where everything gets attached to. And you can see here now, I can show you where R2, R3, R4, these are all the resistors, where they get plugged into. So that's my control system, and it seems to be working. So let's take a look at it live here, and I'll show you, in detail what it actually looks like and kind of where all the wires go.
Okay everyone, so let's take a look at these two boards. You can see how they're connected here. We've got some wires going from the shield all the way to my board that I created, and let's just take a look at the shield first of all. So here are the three stepper motor drivers. This is the top, middle, and bottom. And if I take one of these off here, that's what the driver looks like. So I've got in my PDF, I've got a description about the part number for that guy. So there are a couple jumpers here. There's a jumper here, like I said, underneath those ones as well. This guy's not even being used. And then I have a jumper here to engage the whole thing. And that's basically all you need to do. Now, all of these wires here go to my second board, and I'm just soldering them on, and I'm putting some heat shrink on them. I'll finish that up right before I'm ready to install this thing and make sure all the connections are done properly. But these all go to the digital pins on the Uno, so you know, number 8, 9, 10, whatever. It's all in the code too that corresponds with all of this. And then I just have two sets of wires that are coming for power. This one here comes from this board that gets 12 volts and it goes to the stepper motors. This one here gets 5 volts to power up the Uno and this driver board. So that's that board anyways, and let's move on to the next one. So this guy here I designed off of one of these, just a perf board, and I put my parts on here that I ordered separately, and I've got my nano, and yeah, I'm using two Arduinos, one for the CNC shield and then one for this. I'm not the greatest coder. I'm doing my best and it seems to be working the way I have it right now. This guy here controls all the LEDs and the other one controls everything else. I've got my DF Player Mini, I've got my resistors that run this guy and other little accessories, and then along here I've got a bunch of pins and they all go to the digital pins on the Uno, and they're just receiving signals from all of my things that are plugged into this strip here. So I've got like LED lights and I've got servos and limit switches. They all plug directly in and then send the signals to the Uno, which knows what to do with them in the code. I also have this guy here. He is a amplifier that I bought off Amazon just to try it out, make this a little bit louder. It works, but the potentiometer is not the greatest. I would probably unsolder that and solder a better potentiometer in, and that you could maybe activate from the back of them. And also the 3 pins that it comes with, or the 4 pins it comes with, are actually installed the other way. They're sticking out, and there's no way to put this board on anything. So what I did is I unsoldered them, flipped them around so that they could go into the perf board and solder up that way. And then I have this capacitor for my NeoPixels so they don't burn out. And then my buck converter where I have 12 volts coming in, 12 volts going out, and then 5 volts going out to my other board. So if I just show you what the back of this looks like, I know I could probably design this in software and have it professionally made, but this is like another one-off for me, so it took me about a half an hour to put this together. And it's pretty secure, so I'm happy with that. And then a really cool gadget that I've been using is one of these. Instead of using a switch to activate the self-destruct, I'm using this touch switch, which is amazing. It's so tiny and it only has 3 little wires, just like a regular switch would have. But all you do is you bring your finger close to this, the LED turns on and it activates the self-destruct sequence. So what I'm going to do is I'm going to hide this somewhat and put it onto the back of his shoulder so that if I come up to him and say, hey IG, there's stormtroopers all around us, it'll go into self-destruct mode for about 30 seconds or so. That's my setup, and then these 2 boards are going to be sandwiched together inside that enclosure, kind of like that. And then I'm going to hopefully be able to fit in my power jack onto the back panel, my plug for my power, and then I'm going to make a little slot actually for this wire to come out of the back panel to go into his back shoulder or something like that. So that's the setup. Let's put it all together, wire it up, and I can show you a little demo of what it looks like. So here's a quick demo of how it's all working before it actually goes into the full body. As you can see here, I actually 3D printed this again. It's got the holes for the switch, the DC plug, and then I put a notch in here for the touchpad to come through and attach to the back or shoulder somewhere. So that's all finished being printed. The other thing is I found that the center piece of the eye is very fragile, so I remodeled it. I made it a little bit beefier. It still works, but just printed that out of PLA, and I put the LED lights inside. And then down here I've got this set up with the touchpad just on top so you can see how it works. So I'll just fire it up and you can take a look. So it'll center there, it'll reset there, and then the middle one moves into random positions. And then here's how the self-destruct works. And then the detonator comes out, flashes for a bit, goes back in.
I will disengage self-destruct initiative.
And then back to random movements. I mean, the steppers skip a little bit here and there, but it's not too bad. I'm pretty happy with it overall. I think that's a wrap for that one, and I will start preparing all of the parts to get ready for paint.
Well done.
Hey, thanks a lot for joining me in this episode, everyone. I really appreciate it. We're going to start sanding and prepping parts for paint, and hopefully get this guy assembled sooner than later. God bless you, and we'll see you real soon.